So hello one and all, I'm Deepika Jain. I would be hosting this session. This would be moderated by me. On behalf of Global Knowledge Research Foundation, it is my great pleasure to welcome you to the International Congress on Information and Communication Technology, London, United Kingdom. The 8th edition of the conference is being organized in a hybrid mode. The physical event was held in London, UK on 20th and 21st February, and the virtual event will be held through Zoom today and tomorrow. That is 22nd and 3rd February 2023. I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 6 presentations. Each presentation will be given 12 minutes for the presentation and 2 to 3 minutes for question and answers. On 10 minutes, I will give a reminder check. So please stick to the deadline of which we are giving you. It should not exceed more than 15 minutes as we have parallel sessions continuously as well. So to avoid the delay, please stick to the time. And there is another request to all the participants that please stay connected till the closing remarks. If you have any query, you can drop me and message in the chat box, which is open to all. Okay, just before we get started, I would like to introduce to our session chair. Just a minute. Dr. Amita Sharma. She is a senior assistant professor in Department of Computer Science and IT, the IS University. She has more than 13 years of teaching experience. Her area of interest includes software engineering, networking and security, data mining, and knowledge discovery, database systems, and others. I welcome you, ma'am. We also have our, just a minute. One more session chair with us, Anna Follow Moanda. Please pardon me if you am spelling your name wrong. Yeah, so it is, she is a lecturer at Tshwane University of Technology, South Africa. She has completed her Bachelor of Technology and Master of Technology in Intelligent Industrial Systems. And she also holds a degree in MSc Electronics from Paris. I welcome you, ma'am. Ma'am, if you would like to introduce about yourself for a minute, you are open to do that so as well.
Dr. Amita, would you like to start?
No, ma'am, you can continue. You can share your views.
Yeah, so my name is Diana. I am a lecturer at the Tshwane University of Technology. And then the rest of the time, I am a data scientist at a company called Predictive Insights in South Africa as well. So I am, my biggest field of interest is anything data, anything AI. And I am excited to hear everything that's going to be shared here. Thank you.
Okay, so do we have our first presenter? Ma'am Amita Sharma, would you like to say as well something?
Yes, I welcome all the participants, and it'll be great to learn about your presentations and your research work. My core area is definitely artificial intelligence and machine learning, and I'm more towards medical science and bioinformatics based database. I'm exploring that, and I hope this session will also give more insight in my research, and I definitely I would help to bring some new knowledge to your presentations. So welcome all the speakers, and I request the host to start the session.
Yes, ma'am. So we have our first presenter, Evan A. Sario, who would be presenting a paper on a social critical analysis on Philippine higher education in the time of COVID-19 pandemic towards a framework on flexible learning. Evan, can you hear me?
Good evening, ma'am, from the Philippines.
Yes. Yeah.
Professor
Yeah.
Dr. Alvin Pano. May I now proceed?
Yes, yes, you can start with your presentation. You can share your screen now.
Allow me to share my screen.
Yes, please.
Okay, so
Yes.
basically, the title of the paper is Philippine Higher Education in the Time of COVID-19 Pandemic Towards a Framework on Flexible Learning. This is basically a collaborative work among Mapua University, National University, and University of Santo Tomas Legazpi, all from the Philippines. Basically, the context of the paper is with the shift to online learning and module learning, there is a huge challenge facing the Philippine education that is fully immersed in traditional modalities. There's a need to create a framework on online learning and Philippine education in the time of COVID-19 pandemic based on educational praxis and philosophies of education. Hence, the significance of the paper is hopefully the study provides alternative perspective on Philippine education in consideration of various philosophies of education given the context of COVID-19 pandemic, and in effect, we are challenged to create a framework to address the said concerns. So the study has three objectives. These are, first, to determine the status of flexible learning in Philippine education in the time of COVID-19 pandemic. Second, to provide challenges given the status. And third, articulate principles to guide in addressing issues pertaining to flexible learning in our higher education system. The study is guided by two theoretical frames. First, that of Anderson's theory of online learning, and second, Mishra and Coller's TPAC model. Hopefully, with these two theories focused on online learning, content, pedagogy, technology, interaction, hopefully we will be able to be guided to articulate a certain framework that would describe flexible learning in a given context of crisis such as COVID-19 pandemic. With that, the focus on Anderson's theory of online learning is on first, knowledge and content interface. Second, the interface between teacher and student. And third, the different learning approaches needed in the context of online distance learning. In the case of Mishra and Coller's TPAC framework, it considers first, the set of pedagogical, content, and technological knowledge, and the interaction of these three factors, content, pedagogy, and technology, and hopefully to arrive at a contextualized flexible learning. With such, this is the conceptual framework model of this study. With the two theories on flexible learning and Philippine higher education, with the use of qualitative basic research, specifically social critical research, we'll be able to identify the status, have some analysis, and articulate some principles and mechanisms that would pave the way for a framework on flexible learning, hopefully contributory to a more effective learning processes in higher education, especially in the Philippines. For the methods, basically the paper is a basic research. The research type is qualitative. The approach used is social critical research. The data gathering tools and techniques utilized are document analysis and secondary data analysis. As advocacy lens, we adopt educational praxis in the context of the two theoretical frames mentioned. So let us proceed with the first objective on status. Based on the results of our study, we have noticed some status of Philippine higher education. First, there is an issue on the level of readiness of Philippine higher education system. Seemingly, the entire higher education system in the Philippines is outcomes-based education focused. But somehow it is not flexible, creative, and innovative because totally it is traditional in framework and there's a need for an alternative system because given the case of crisis such as COVID-19 pandemic situation, the alternative system is not in place and therefore compromises the actual delivery of teaching learning processes. Hopefully, the possible measures to address such status or challenge is to have various delivery modes of learning systems to be incorporated as educational policy mandatory to all higher education institutions. The second status is actually on the level of competence of Philippine higher education institutions. There's a need to have a revision on the curricula, syllabi, and modules for the degree programs because seemingly, given the COVID-19 pandemic, they are no longer appropriate for an alternative system in the case of a crisis. For example, infrastructures have to be built in these institutions. So the possible measures that we can do are, one, curricula, syllabi, and modules are designed not only for traditional style of teaching and learning, and that infrastructures should be mandatory to all higher education institutions, especially on information and communication technology. On status 3, it's on the level of skills of higher education teachers. Higher education teachers are not capacitated for technological enrichment to reckon content and pedagogy. As we know, the challenge in online learning and modular distance learning is given our content and pedagogy, how to utilize technology to improve much the delivery of teaching and learning processes. So one measure for this is to actually have capacity building programs for teachers to enrich their pedagogical styles and their innovativeness in the use of technology-based applications. On status 4, it's on the level of practicability for higher education students. Higher education students find the flexible learning not workable given reasonable factors. One, issue on the strength of internet connectivity. Second, the quality of modules provided. Third, validity of assessment given online learning and modular distance learning. Third, availability of learning device. And last, availability of budget for net data and the conduciveness of households for online learning and modular distance learning. The possible measures for these are, one, there should be modules that are standardized, normativized, and effective, produced by the government and higher education institutions. Second, requirements have to be simple, reasonable, and workable, given time, resources, and capacity of students. Third, assessment should not be traditional and objective, but should be authentic assessments. And last, modules have to be the default system. On status 5, it is on the level of adjustments of higher education stakeholders. By stakeholders, we mean parents, community, local government units, and people's organizations. Challenges are, one, parents are not equipped to assist learning of their children. Second, the demand for higher budget for studies, especially for the requirements. Third, uncertainties of the community in the quality of education provided. And fourth, the nature of intervention of local government units and people's organizations are not that clear and distinct. So the measures for these could be, one, there should be new but rationalized guidelines for the fees of the schools, colleges, and universities. And second, students, even in the private schools, have to be subsidized by the government. So given those status, there are some challenges. No, one, there's a need to reframe the entire
Dear
Philippine
presenter, you just have 2 minutes left, so please hurry up.
Yes. Last point. Second, there's a need to reformulate learning outcomes. Third, there's a need to revisit the curricula of all degree programs. Fourth, there's a need to refocus higher education to educational technology. And fifth, there's a need to recast involvement of stakeholders in education. Hence, in order for us to arrive at a model on flexible learning focused on that it should be community-based and context-relevant, it should be a form of critical pedagogy, it should adopt or anchored on experiential learning and progressive education, it should be a measure of quality standards in education, and that it has to be political. That's all. Thank you very much.
Ma'am, any questions?
There are questions in the chat. I want to say this is a very interesting for me because I think we're going through the same types of problems in Africa, especially like since COVID, and we had to move some studying online. Students don't have access to some things, and as you said, like the governments need to kind of be involved to make this happen. And I have one question. They say you need to make assessment authentic, not traditional. What would that mean in practice?
Yes, by authentic assessment, usually traditionally we focus much on objective tests, quizzes, traditional recitation. But during the pandemic, we should focus on authentic assessments. These are fundamentally performance tasks that can be given to students for them to exercise or demonstrate the required relevant competencies as desired by a given course. Hence, the focus now is not on actually knowledge or understanding level, but more on the applying, analyzing, evaluating, creating levels of competencies in their actual learning processes. And so therefore, it's not actually focused more on actual objective tests, rather on performance tasks of students.
Yes,
Thank you.
I just have a small question. You just mentioned about the outcome-based learning. How much, what is the real perspective in case of the national policy if you have in your country? What is the perspective of your national policy with respect to outcome-based? And how you see your research will be helpful in framing or redesigning your policy, education policy?
Yes, the Philippines actually adopts as an educational policy, it adopts outcomes-based education. Basically, a version both of the United States and and Europe, no? Outcomes-based education. Given that that is the national policy of the Philippine education system, it's actually somehow quite good. The challenge, though, is to reframe it in such a way that it should be adaptable, it should be adjustable, given different situations, especially during the COVID-19 pandemic. I must say, all higher education institutions are basically challenged how to recreate curricula, syllabi, and modules, adapting outcomes-based education and translate them to students who are actually having some challenges in their actual online learning and modular distance learning. That means when we tailor fit outcomes-based education, given COVID-19 pandemic, for example, it has to be community-based, it has to be relevant, it should consider the actual situation of teachers, students, community, and therefore focus more on performance tasks, let us say, and not on the traditional setup of higher education institutions.
Thank you so much. It was really good.
We'll move with our next presentation. That is, it would be presented by Nabila Nasser. She would be presenting a paper on anomaly detection in orthopedic musculoskeletal radiographs using deep learning. Nabila, are you here?
Yes. So I will
Please
share.
begin with your presentation. Yes, please.
So hello everyone. I would like first to thank you for your interest that you have shown to my work, anomaly detection in orthopedic musculoskeletal radiographs using deep learning. This work has been realized with the assistance of Professor Lanoui, Professor Mekram, and Professor Leslie, that I thank very much for the great effort they have provided with me. And to carry out this presentation, I will start with the abstract introduction, followed with the literature review and proposed methodology, and problem and needs assessment. Then I will start to experiment results to finally pass to the conclusion and future work. So, anomaly detection in orthopedics musculoskeletal radiographs using deep learning. We examined 13 models for the most powerful neural network families: the generative adversarial network, autoencoders, and convolutional neural network. The main goal is to detect anomalies in musculoskeletal radiographs using the Stanford musculoskeletal radiographs MURA dataset. The results of the examined models were compared to several recent studies. Generally, CNN models achieved the best score with the of 0.92, which is comparable to the performance of experiment radiologists. So musculoskeletal anomalies are the most frequent pathology, long-term pain and disability, which makes detecting anomalies in radiographs correctly a crucial task in the medical world. Analyze X-ray for diagnosing orthopedics disease, bone malformation, tumors, fractures, etc. is a time-consuming and require qualified experts. Therefore, developing a computer-aided diagnostic system to search for anomalies has become attractive in X-ray images. In this way, we explore the use of artificial intelligence, particularly deep learning, to provide diagnostic assistance to a radiologist to improve the quality of patient care and reducing time of diagnosis. Several models have been investigated in this direction, such as convolutional neural network, autoencoders, and generative adversarial network. So our contribution to this work can be summarized as follows. So review the examined deep learning models approach and architecture. Pre-processing techniques are applied on radiographs. Combine some models to form an ensemble model to improve performance. And finally, comparison analysis are made between the whole examined models. So the problematic. So what a proactive approach should be adopted for a better integration of artificial intelligence to detect anomalies in orthopedic musculoskeletal radiographs. So as we said. So in our work, we achieved the proposed system. We must take with consideration the following needs. So the proposed models must be powerful to manage large volumes of data, genetics to manage the different distribution of type of the different entities, and supervised to get around the problem of unenabled data, scalable to adapt the new cases of anomalies, and manage anomalies that are closer to the normal user behavior. So, as we said, anomaly musculoskeletal detection on radiographs is a time-consuming and requires qualified experts. Therefore, many researchers work on developing a computer-aided diagnostic system to search for anomalies in X-ray imaging. In this table, we present the previous studies on anomaly detection task. Many researchers have trained the convolutional neural network on bone X-ray image. In others, use transfer learning techniques such as feature extraction and fine-tuning musculoskeletal anomalies detection on X-ray imaging. Some recent works use deep learning detection methods such as GAN and autoencoders to improve the anomaly detection. So researchers try to improve the performance of those mentioned models by changing their components. So we illustrate the various techniques of anomaly detection. Given the large number of anomaly detection algorithms, we have chosen to work mainly with autoencoders, CNN, and GAN. So the goal of an autoencoder is to learn a representation encoding for a data set, typically for dimensionality reduction. Deep autoencoder is composed of two deep symmetric networks used to reproduce the input at the output layer. So the convolutional neural network is a feed-forward neural network. It's composed of many convolutional layers stacked on the top of each other, each one capable of recognizing more sophisticated shapes. The final family is GAN. So the learning of GAN takes place several steps. From a random distribution, the noise of a transformer to generate to generator, which will be subsequently generate false pair with label y equals 0. The discriminator receives the false pair produced by the generator and the real pair which has been labeled with y equal 1. So the discriminator and generator calculate the loss. Both losses return to their respective network to learn from the loss and adjust their parameters. The application of an optimization algorithm, GRAD or ADAM, etc. This process loops until a satisfactory level of performance is reached. This mode of computation between the two components allows the generator to generate samples closer to the real data, and the discriminator also becomes increasingly strong to distinguish between false and true data. After having elaborated a benchmark between the different deep learning models applied for anomaly detection, we have opted for VGG, Inception, DisNet, ResNet, MobileNet, Conv ensemble model, VAE, AlphaGAN, and BGAN. For our study, by anticipating efficient results according to the different scientific readings we have done. So we will explore the public dataset MURA. MURA is the largest collection of radiographs images with over 40,000 X-ray images. MURA contains 90 normal and 500 abnormal musculoskeletal radiograph studies of the upper extremity, including the shoulder, humerus, etc. of organs. So looking at the results, at the accuracy of the models implemented above, we can see that they performed within the range of 48.3% to 82%. When comparing our score to the overall score from the Stanford model and the radiologist accuracy, we can see that some of the implemented models in this paper accuracy is comparable. Detailedly in this table that shows the DisNet and ResNet and VGG perform the best and the VAE performs the worst by a large margin. For GANs, we observe accuracy values smaller than 70%. AlphaGAN achieves 60.7% and BGAN with 55%. Wherefore, they still some missing pieces in the current approach of using GAN for anomaly detection that could be solved to improve anomaly detection system. Looking ahead, we think the most significant change we can make for our next work is to find the most effective combination between GAN, autoencoder, and CNN that could give the most performant models for anomaly detection. So in our experience, we compared and analyzed several models against each other for anomaly detection tasks. We concluded that although these models for computer-aided diagnostic may not currently achieve the accuracy needed to replace human interpretation of radiologic studies, they could be very useful to reduce time of diagnosis and minimize of error. Moreover, we see the potential for different model architecture, as well as the possibility of building an ensemble model that could perform better. Therefore, as part of the future work, we want to introduce a different reading approach by introducing an ensemble model, by combining the three families studied in this work in one architecture that could learn specific features for detecting musculoskeletal anomalies. Why not we could visualize the anomaly detection in radiographs and detect and apply multi-classification of fracture types. That's all. Thank you.
Yes, ma'am. Any questions?
Just a short question. In your review where you mentioned different papers, and there you mentioned that there are different models whose accuracy was also mentioned. So one of the model was UNet++, whose accuracy was around 0.92 something. And rest models in the review part, You have reviewed certain models now?
Yes.
Yes. Here you can say that unit gen is giving 0.2 accuracy. I think these are all accuracies.
Yes,
Yeah.
these are all
So
accuracies.
why haven't you used this model for your review purpose or for your first stage experiment? Because the accuracy of this is much better than other models. And
Yes,
even
so
when you just generated the result and received the outcome, you can see they are just generating very low results in comparison to unit. So my suggestion, just to you should go for unit because it give good result even in 2D and 3D both images. Then you can combine different approach, whether you want to use a autoencoder or any other techniques to get or improvise the or increase the efficiency or precision, whatever the factor you are considering for your evaluation. This is
yes,
just one suggestion from my side.
yes, thank you. Thank you.
On my side, I just want to have a little bit information. GAN is generally used for generating samples that look like what's in the training set. So how did you use it for classification purposes? Or what was the purpose of GAN in your methodology? I just want to make sure that I understand where GAN
Yes.
was used.
Yes. So exactly as you said, so GAN is in the first place was created to generate false data samples closer to real data. So we explored this part to have a competitive learning. So as I said, so the generator will generate from the noise, samples that closer to real data. And the discriminator will receive the false pair produced by the generator and the real pair, the real data. So the discriminator will distinguish between the real pair and the false pair generated by the generator. So it's this mode of competition between the two components, the generator and the discriminator, allows the generator to generate samples closer to the real data. And the discriminator becomes increasingly strong to distinguish between false and the true data.
Okay, thank you.
Thank you.
Thank you. Thank you for your presentation, Nabila. We'll move forward. We have our next presenter, Philane, who would be presenting a paper on integrating IoT sensors to set up a digital twin of a mixed model stochastic system for real-time monitoring. Philane, are you here?
Yes, I'm here, ma'am.
Yeah, you can
Let me
start
share my
sharing your screen.
Can everyone see my screen?
Yes. You can start.
Okay, greetings everyone. My name is Pilani Shabalala, and the title of my paper is Integrating IoT Sensors to Set Up a Digital Twin of a Mixed Model Stochastic System for Real-Time Monitoring. So here is the presentation table of contents. So the competitiveness of the current market forces manufacturing firms to stay efficient and produce quality products as there are no room for errors. This means that in order for a company to remain competitive globally, it must adapt to new technologies. One such technology is real-time monitoring. So real-time monitoring is critical as it allows operators and engineers to see and respond to events such as downtime and faults in real time. Real-time is a term that can be defined as the ability of the system to respond to any swift change in a way that the response is almost at the same time that the error or event occurs on. So some of the challenges in today's market are high demands in product variety, shorter lead times, and a need for a virtual system that can do real-time monitoring, prediction, and controlling. Therefore, this research proposes a data-driven digital twin as a possible solution. So a digital twin can be
Sorry, can I
defined
just
as...
ask you to make it full screen? Can you share your slide full screen, please?
Is it full screen now?
Yes, thank you.
Okay, so a digital twin can be defined as a virtual copy of a real-world system that is designed to monitor, simulate, predict, and control the conditions of this system using its historical data and the live data that comes from the sensors. So digital twins aim to support digital transformation as they offer a number of advantages such as reduce cost and optimize production, making them a possible solution for several problems in Industry 4.0. So this research looks at the design and development of a data-driven digital twin for a mixed model stochastic system or assembly line. So an assembly line can be defined as a production line that is made of workstations where products flow from one workstation to another using a conveyor belt as a transportation system. So we have three types of assembly lines. We have single model assembly lines. These are assembly lines whereby only a single product is produced at a time. And then we have multi-model assembly lines. These are assembly lines whereby multiple products are produced and divided into batches. And then the last one is the mixed model assembly lines. These assembly lines are capable of producing a variety of products at the same time without any changes to their sequencing. So the time it takes a single workstation to complete all the tasks that are assigned to it is referred to as task time. So task time can either be deterministic or it can be stochastic. Deterministic task times, it's assembly lines whereby the inputs are known and they are constant throughout the entire production. And then stochastic task times is assembly lines whereby you cannot predict the input because the inputs, they vary throughout the entire production. So this research uses the case study of the water bottling plant at the Central University of Technology here in South Africa. So this water bottling plant is made of three workstations, which are referred to as smart manufacturing units, SMUs. So it has three SMUs, SMU1 being the filling station, SMU2 being the canning station, and then SMU3 being the packaging station. So here I've attached a video of how this plant actually operates in real life. So as you can see, the entire process is driven by the Siemens S7 PLCs. So the PLCs triggers that pump and then the filling starts. So the bottle is still in SMU1. And then after the filling is done, the bottle will then now move to our second SMU, which is the capping station. So the capping station uses this Festo pneumatic arm to cap these bottles. And then after capping these bottles, it will then move into the third SMU, which is the packaging station. But unfortunately, I don't have the third SMU on this video because it is still under construction. So these are some of the existing methods that are used currently for real-time monitoring. So we have data acquisition systems, which can be defined as a technique that is used for digitizing the data that comes from the sensors so it can be stored in computers where it will be displayed and analyzed. And then we have lean manufacturing, which is an approach that aims at exceeding the customer's expectation by continuously reducing all kinds of waste in the manufacturing process to enhance production and produce products at lower cost. And lastly, we have cloud manufacturing, which is a new paradigm that is made of existing manufacturing models with the support of new technologies such as cloud computing and IoTs with the aim to keep the production efficient and promote collaborations within the industry. So however, these existing methods have their limitations. So the limitations of data acquisition system is that they come in with built-in sensors, therefore making them being able to be utilized only for specific applications. And also initial training is required for new users and programmers. And then the limitation of lean manufacturing is that it takes time to give feedback as it wants to give out an accurate response. So lean manufacturing must be used with other emerging technologies such as cloud manufacturing in order to defeat this time factor. And then lastly, the limitations of cloud manufacturing are network outages and a risk of unexpected downtime since cloud manufacturing is an internet-based system. So here is the methodology. So in any real-time monitoring system, one of the first and important stages is the selection of the IoT sensors, as a wrong selection may lead into the system not functioning as expected. So here I've selected my IoT sensors and I'll be using the Arduino Uno microcontroller as the brain of the system, as it is the one that is responsible for collecting the live data from these sensors. And then with the help of the ESP01, which is a Wi-Fi module, this data will then be sent to a cloud server by the name ThinkSpeak. So here is the proposed setup of this water bottling plant, which is our mixed model stochastic system. So on this picture, you can see where I'll be installing these IoT sensors in these different workstations to monitor the raw materials of this plant. And then here is the data-driven digital twin that is developed using the software called MATLAB and Simulink. So this model is capable of reading or live streaming the data from ThinkSpeak and using it as its input to do cycle time calculations, predictions, and also real-time monitoring. So here is ThinkSpeak. So a channel by the name water bottling plant was created with 3 fields to monitor the raw materials, the water level, bottles, the flow rate. But it should be noted that the data that is displayed here was just for testing purposes. So if you've noticed from the previous slide that you can see from the water level, it's around about 58 centimeters. And you can see from this data-driven twin that this data digital twin that the last value here is 58. So it's going to use it as its input to do cycle time calculations and real-time monitoring. Also, you can see the number of those 500 ml bottles. It's 8. And then the flow rate is around about 36. Also here you can see that it takes the last values so that it can do these calculations in real time and predictions in real time and also real-time monitoring in real time using this dashboard. So you can see that water levels there around about 58 centimeters, the number of filled and capped bottles, they are 8, and then the flow rate there by 36 liters per minute. So as part of future work or conclusion and future work, this digital twin now will be used for this water bottling plant to do real-time monitoring of these raw materials and also real-time predictions. And it will also be used to reduce the cycle time and optimize the production. And also a digital schedule will be created for this water bottling plant. And then the output of the digital schedule will be compared to the output of the digital twin to showcase the impact that the digital twin has on the efficiency of this plant. It is hypothesized that the ability of digital twins to use live data as inputs will reduce the cycle time better compared to the digital schedule. Thank you very much.
Thank you for your presentation. Any questions, ma'am?
No questions from my side. Thank you.
Just a short question. What are the general performance parameters for digital twin?
What are the general performance parameters?
Yes.
Can you
Are
please,
there any parameters? Or matrices?
matrices. No, digital twin, it can also be used with other imaging technologies. For example, you can use it for with neural networks for predictions and all, but this is a new installation, so there is no historical data. So that's why I decided it will be just a data-driven digital twin for real-time monitoring, just to monitor the raw materials.
Okay, thank you so much.
Thank you very much.
Thank you. Thank you. So we have our next presenter, Khaled, who would be presenting a paper on overlay robotized data center system. Are you here?
Yes, good morning,
Yeah.
everyone. Greeting from United States.
Yeah.
Let me share my presentation.
Yes, yes, please. You can start.
Ladies and gentlemen, first off, it was a great honor to have the opportunity to contribute to this conference. Our topic today is going to be overlay robotized data center system. Dr. Hussam al-Bahiri and I share the enthusiasm about science, and especially when it comes to the future technological evolution science. So let's begin. Our presentation begins with an overview. We will also cover the data center technology and robotic industry. The last item on our agenda is our primary topic, which is overlay robotized data center, which is our proposal. As always, we will end up with a conclusion to summarize the presentation. From internet that is everywhere and it becomes a must to everywhere we go, to stock market that it becomes in the palm of your hand on an application that enables to manipulate hundreds of millions of dollars. And with the 5G technology embedded in every gadget in our lives, along with the IoT that exists in every household, from Alexa, Google Assistant, to cameras, and the refrigerator recently that it ordered milk from the grocery store on its own when it detects that we ran out of milk. Folks, data is a new source of wealth for the 21st century. Data can be more worth than gold and oil. Let's give a background. What is a data center? A few decades ago, the ordinary way to run an application was through a personal computer, and to store the data was on the local hard drive or external one. But over time, with the exponential growth of technology in many fields, a centralized dedicated building or group of buildings to house bigger computing system to serve millions, if not billions of users, and capable of storing all the data as well, what we call it today, data center. Data center capacity varies depending on the service that they offer to the consumers. The bigger ones called hyperscale data centers, such as what public cloud provider has, such as Amazon AWS, Microsoft Azure, Google GCP. And IoT, 5G, and artificial intelligence, all these technologies are the major drive behind increasing the demand for more data center infrastructure to host more computing capacity, and in turn, that consumes more energy. Unfortunately, the time to build those data centers and get them ready to accommodate to the technology and business demands are not in correlation. This is a significant gap. The gap is constantly growing, even with considering all energy resources in the future. Second topic we need to cover is robotics. The development of intelligent robots help humans to achieve things that currently seem impossible, such as dangerous or daring environments. And on the other hand, artificial intelligence become inseparable from robotics. Robotics and artificial intelligence together are disruptive technological approach for many industries. As we can see, The robotic industry is growing, and the dependency on robotic industry is not backing down anytime. So we got two problems on our hand. So what do? Exactly. It's our proposal. Overlay robotized data center system. Using the robotics into the data center will definitely consider a big help. Certainly, there are some visionary 3D, CGI, 4K, graphical futuristic documentary on Discovery channels, and those 10 to 20 years in the future. However, we need that today to solve the issue we have in hand. Our proposed solution is for today, and it's for tomorrow, and continue years from now. The design is fundamentally based on deploying a commercial robotic system in the existing data center, which we call a brownfield. The robotic mechanism would be able to move around between the rack-mounted equipment in the aisles of the data center floors. The robotic arms would come with different types of replaceable accessories and different purposes. The robotic arm system could be single unit per aisle rail to handle a task for equipment deployment, or it could be a dual unit fashion to handle multiple functions simultaneously on one aisle. Let's watch together a quick 3D model of the proposed design. Yeah, that was a lot to take in just 10 minutes between data centers, robotic industry, and deployment all together. So let's sum it up. Overlay robotized data center system is multi-purpose design, support heavy and lightweight deployment in any data center. It's designed to support the brownfield, which is the existing data centers, or the greenfield, the newer one, with a faster deployment fashion. Definitely, it reduces unemployment rate. It reduces human injury rate. It's considered unprecedented opportunities for people with disability. I just want to say thank you very much for your time, and truly much appreciated. We are ready for questions.
Thank you. Thank you for your presentation. Any questions, ma'am?
I want to know, it seems like this might be a costly venture. What is the, what do you say? Is there a balance between the costs that this could create versus the benefits that it could provide? And if yes, is such a study being done? Like, do we actually have numbers or any idea? Thanks.
Yeah, actually, it's not only the study has been done already, the implementation, okay, has already been done in one of our data center, because next to my job as a professor with DeVry University, I work actually with the biggest ISP in the United States with Charlotte Communication. And I have given the opportunity to try to implement that. And it's actually really cool that it saves a lot of money, especially when you think about what happened with the pandemic. We had a lot of shutdown because of the pandemic. You can continue the work using these actually mechanisms, and you can implement the existing data center and the green one as well. I hope I answered your question briefly.
Yes, thank you.
Thank you.
No
Thank you,
questions
ma'am.
from my side.
Okay, ma'am. Thank you so much. So we'll move
Much
on to our
appreciated.
next presentation, that is by Anja, who would be presenting a paper on using conceptual chunking to support information processing while solving complex industrial tasks. Are you ready?
Yes, thank you.
Yes, please start sharing your screen.
All right, I hope you see it now.
Yes, yes.
Okay, so welcome to my talk about how chunking changes information processing in complex machining tasks. I studied psychology, and it's my primary interest to understand the human cognitive system with its strengths and pitfalls. I'm now working in engineering, so we are trying to help design machines and production systems in a way that fits the human cognitive system and is adaptive to human skills and knowledge. This is especially important and challenging as systems become increasingly complex and with increasing levels of automation. It is really important that we do not lose human expert knowledge in the process. In short, we would like to design systems so they support human information processing and thereby facilitating human machine teaming. Understanding human information processing is an important issue to get deeper insight into human thinking and to improve the interaction with the environment. One example in which the understanding of cognitive processes is enormously important is the field of human-machine interaction in the industrial context. Many control tasks, such as supervision, pose high requirements on the human cognitive system in order to operate machines efficiently, keep technical processes stable, and avoid accidents and risk for human operators. Mostly, the operator has to control and adjust multiple interacting variables at any given time in complex and dynamically changing technical systems. Therefore, these systems should be designed in accordance with the strengths of the cognitive system to allow teaming. That is, the operator needs to understand it, at least to a certain degree. But however, the technical system become more and more complex, and this can exceed working memory capacity of the operator. Therefore, strategies to enhance working memory capacity, such as clustering information, are needed. This so-called chunking is a storage of smaller units of information into larger units. In this manufacturing context, it is important that not only the information unit itself is integrated, but also their relations. That is what distinguishes this conceptual chunking from the chunking that was described by Miller in 1956. Visualizations can be particularly helpful in communicating these relations because they might induce conceptual chunking, helping the operator to create and understand the situation with low memory costs. So we assume that participants understanding benefits from the right visualizations, that participants are able to solve tasks faster and more accurately when they use conceptual chunking, and that participants are able to solve the task without additional information search if participants use conceptual chunking, which is induced by a visualization. We used thermal spraying as an application. Here, a human operator has to monitor and control spraying units. During the coating process, material such as powder particles is melted by high energy sources, for example, plasma, and sprayed onto prepared work pieces. It is important that the spraying process has the exact temperature, which is dependent on other variables, such as the mixture of processing gases, for example, hydrogen and argon, needed for plasma generation. If the process fails, the resulting surface is of low quality. With this application, we constructed a simplified experimental task to study chunking processes under controlled conditions. The study comprised 3 parts. First, the instruction phase, in which participants had continuous access to all task-relevant explanations and graphical information for both experimental conditions. So this is this phase where participants were taught about thermal spraying and saw either this or this, so the top or the bottom visualization. And during the second part, the practice phase, the application of the task-relevant knowledge from the instruction phase was tested. And during a third phase, 10 different tasks to adjust the technical systems were had to be executed by the participants without the possibility to return to the instruction. And as I already said, we manipulated the visualizations. On the one hand, the coordinate systems are able to transport relations between variables, making them suitable to induce conceptual chunking. So that's what you see at the top visualizations. And on the other hand, side-by-side bar graphs do not display any relations, thereby constraining chunking. We analyzed cognitive workload at 3 points in time, which was before participants learned anything, after the practice phase, and at the very end. And we also measured gaze, so gaze behavior of the participants during the learning phase, where participants learned about our application, during the practice phase, and during the final test phase. During this test phase, they had to solve a single choice task in which we showed them a current state of the system, and they had to choose 1 out of 4 options to adjust the system so it would run as good as possible. We had a student sample to control prior knowledge. So we were really concerned with what people knew beforehand. So they all had the same starting point. In a follow-up study, we are now also testing different levels of expertise, but here we try to keep that variable really the same for everyone. For both conditions, gaze data showed that the written explanation were used most frequently. This might be due to the fact that reading information takes longer than encoding visual stimuli. However, participants in the chunked condition used the graphic presentation more extensively than participants in the unchunked condition. So that is, participants looked much more at the coordinate system than to the side-by-side bar graph. If they had to learn the material with a side-by-side bar graph, they usually focused on the written explanation and not on the visualization. This indicates that graphic presentation displaying the relation between variables are suitable to support the understanding of complex tasks. Participants in the chunked condition use the relations between variables, that is the ratio between the process gases, more than twice as often, indicating that the coordinate system supported the understanding of complex processes. Moreover, there was a higher response accuracy and a tendency for a lower response time in a chunked condition. So when people had a coordinate system and were able to learn the relationship between the variables, they were faster and more accurate, which is a really good result for us. We also could show that participants that used conceptual chunking, so that really used this relation between variables in order to solve the tasks, that those participants worked more efficiently. That is, they did not look for additional information in order to exclude some answering options, but only looked at the right answering alternative, which is why we used eye tracking data. So to conclude, we can say that creating the best visualization is still an iterative process that grows with each study and the analysis of more fine-grained measures. The coordinate system did not induce conceptual chunking very reliable, but it induce much better than the bar graph. So we still have to investigate other forms of visualizations. For instance, stacked bar graphs are an additional way to visualize relations, especially proportions between variables. However, the results indicate that graphic presentations displaying relations between variables seem to be suitable to support the understanding of complex tasks, the understanding of memory processes involved in monitoring and controlling industrial applications, the design of cognitive efficient visualizations, and the utilization of suitable research methods are small building block for supporting human operators in their complex and challenging tasks in a responsible way. So therefore, based on the study, we are currently developing and testing more elaborate visualizations that address the human information processing when working with complex system and variable degrees of automations. Thank you. So, are there any questions?
Quick question. What will be the suggestive guideline from your side?
We are currently working with expert knowledge, so people who are really confident with what they are doing. And currently we are trying to give them as less information as possible so they can use their expert knowledge. So I can't really give you one design guideline because it really depends on the human operators, on individual differences of the operator. But we are working on visualizations that adapt to these individual differences, such as expertise, for instance. So operators should get exactly what they need to know, not more and not less, because more does confuse them, and less also because they don't have what they need.
Thank you so much.
Thank you everyone for your presentation. So we have come to our closing remarks. Just a minute. I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of the entire team, thank you for your support during this 8th version of this conference. We would be happy to see you in the 9th version of this conference as well. All the presenters would be getting their certificates through email within 2 working days. Further, all the papers have already been forwarded to the Springer. The publication will be live within 6 months. Kindly cooperate with the team of ICICT 2023. I also thank our session chair, Amita Sharma. Just a minute now. For your wonderful contribution to the team of ICICT. This is a token of appreciation for you, ma'am, as well as Diana Follow, Moanda, for you as well, ma'am. Thank you so much for chairing the session. It was wonderful to have you here as well. I request all the participants to, on their camera for a quick snapshot of the virtual conference. So yeah, a minute. Thank you so much, everyone.